At this point, you should be able to determine the degree of a polynomial by looking at its equation, and you should be able to identify the sign of the lead coefficient. And these things are important to us because they tell us what direction the end behaviors will go for our polynomial function. For example, if you have an odd degree, like a degree 1 or a degree 3, you should know that the end behaviors will go in opposite directions. With even degrees, they go in the same direction. If your leading coefficient is positive for an odd degree function, then you know that you start in quadrant 3 and head to quadrant 1. And that's like a line. If you think a line degree 1, opposite end behaviors, positive slopes go this way. If you have a cubic, you're looking at something that might go like that or have a bump in the middle. But in the end, your end behaviors are opposites. And if it's a positive lead coefficient, it goes from quadrant 3 to quadrant 1, or from negative infinity up to positive infinity. If you have an odd degree with a negative lead coefficient, then your end behaviors go from quadrant 2 down to quadrant 4, or go from positive infinity to negative infinity. If you have an even degree function, your end behaviors should be the same. So think parabola opening up, positive lead coefficient, they both go to positive infinity. If you have a quartic, it looks like a parabola, or could look like a parabola. It might look like a W or a wonky W. But again, positive lead coefficient means they both go to positive infinity. A negative lead coefficient means they both go to negative infinity. Okay, so our goal here today is to determine the y-intercept of a polynomial function and to be able to relate the factored form of the equation to the zeros or x-intercepts of the polynomial function. So just remember that zeros means x-intercepts. Now, you can use that information to sketch graphs or to know what they will look like based on the information that you know from previous lessons as well. So for the y-intercept for any function, whether it's polynomial, exponential, sinusoidal, any kind of function we look at all, the x-coordinate will always equal 0 because any point on the y-axis will always have an x-coordinate, a corresponding x-coordinate of 0. So anytime we want to find a y-intercept, so for a y-intercept, we always let x equal 0 or sub 0 in where the x is. All right, so here we are. For each of the following polynomial functions, predict the degree or state the degree and the sign of the leading coefficient. Use the information to predict the end behaviors of the function, then graph the function using graphing technology and state the x-intercepts. So this first one, if I want the y-intercept, I'm going to let x equal 0. We're going to have x cubed minus 4 times 0, which overall is equal to 0. So our y-intercept is going to be at 0, 0. Our degree for this one is 3, and the sign of the leading coefficient is positive. So if you put that into your Desmos, you're going to find that that graph is going to look something like that. Okay, and our end behaviors are as x approaches negative infinity, our y is going to negative infinity. So it's the same sign on the end behaviors at that point. And as x approaches positive infinity, your y also approaches positive infinity. Okay, now your x-intercepts on this one, if you put it into Desmos, you can find those out. I believe they should be at negative 2, 0. They should be at 0, 0, and at positive 2, 0. All right, fill in the rest of this, and then you can check your work. Okay, I found that my y-intercept was at 0, 0. It had a degree of 3. The sign of the leading coefficient is negative. The end behaviors as x approaches negative infinity, our y is approaching positive infinity, so it's doing something like this. And as x approaches positive infinity, y is approaching negative infinity. And I found my x-intercepts to be at negative 3, 0, 0, 0, and 2, 0. All right, the next question here, part C, I'm going to get you guys to expand and simplify first. Figure out your y-intercept, the degree, the sign of the leading coefficient, the end behaviors, and the zeros. And again, you can use Desmos for the zeros, but the other things you should be able to figure out without that. Okay, hopefully you were able to expand and simplify. Part C, I got negative 2x squared plus 14x minus 24 as my standard form is what that's called. My y-intercept ended up being negative 24, and you'll notice that negative 24 is right here. Remember, in standard form, that constant term at the end is always going to be your y-intercept, simply because when you let x equal 0, the ones that have the x attached to them are going to end up equaling 0. This one had a degree of 2, so it's our friend the parabola, and it's opening down. And so that means the end behaviors are both heading to negative infinity here. And the x-intercepts for this, or the zeros for this, are at 3, 0 and at 4, 0. Now you might also remember that the factored form, which is what we have right here, tells us something about the parabola. And in fact, if you look at the numbers that we have here and here, you'll notice they appear here and here, but opposite sign, of course. Part D, when you expand and simplify that, you end up with x to the 4 minus 13x squared plus 12x. And I should really double check that to make sure I haven't made any mistakes on that. But I got a degree of 4 on that, and my sign of the leading coefficient is positive. My y-intercept ends up being 0. I didn't show all my steps here, but h at 0 ended up equaling 0. Now, this is a degree 4 with a positive lead coefficient. It means I've got that W-shaped curve that looks like this. So as x approaches negative infinity, my y approaches positive infinity. As x approaches positive infinity, y is also positive infinity. And my x-intercepts here are at negative 4, 0, 1, and 3. And you'll notice right here, we've got a 3 here, a 4 here, a 1 here, and this really could be written as x take away 0 there. So determine the factored forms of polynomial in C and D and compare them to their x-intercepts. And what do you notice? So I've already kind of pointed that out to you, but hopefully what you're noticing is that the factored form is what tells you the x-intercepts for any polynomial function. So it's true when we're working with parabolas. It kind of is true also with lines if we think about writing them in their factored form, which we never have done, but if we did, it would also be the x-intercept. So that's what we want to put there in this blank. Okay, so you can get your x-intercepts from the factors by setting each factor equal to 0 and solving the mini equation to determine the x-intercept. So this is what I'm writing right here, or what I'm saying is important right here. So for example, if we had a parabola, and let's say we had y equals 2 bracket 3x minus 1 and a x, nope, let's do something else here, 4 minus x. What I would do is take the factors, which are the brackets here, I'm going to set that equal to 0, so 3x minus 1 equals 0, and I would solve that little mini equation for the x. So I would add 1 to both sides, and we get 3x equals 1. And then, if I were to divide both sides by 3, I'm going to get x equals 1/3 there. So one of my x-intercepts here is 1/3. My other one, I would have 4 minus x equals 0. I could add x to both sides, 4 equals x. My other x-intercept would be at positive 4. So hopefully that makes sense in terms of how we can come up with those x-intercepts from our factored form.